What's up, guys, and welcome to this episode. Today I will going to talk about my two products. These are the connectors for the public charging stations. I was testing my electric BMW on the highway. If you haven't been following, I converted my BMW 839 on the electric drivetrain, and then on the end some educational content about my LED state of charge indicator. This is one of my products that you can buy, a Type 2 connector for public charging station. You can use this all over the world. It has inbuilt electronics with a button for start charging, and on the other side you have here the home socket, so you can charge on this everything you want, from electric bicycle, electric motorcycle, even the electric car if you have only a home plug for charging at home, if you don't have this cable for the public charging stations. And the second one is also the more for do-it-yourself. It also have inbuilt electronic with the button for start charging. Only thing you need to do is solder the wire on the particular pins, and then you can make your own cable for your electric car conversion. And these two are working all over the world in any charging station that you want to charge. And now I will going to show you how this works. So and now we have here electricity. So for example, I have here air heater. I will stop charging. Now press the button, and now it's off. So this is it. Now it's checking, and now I can press the button, and now we have electricity here on pins. So for ordering of these parts, you have my email address below in the descriptions. You can send me an email and order. On my electric car, I was testing the maximum speed on the highway, and the maximum speed is determined by the RPM of the motor, not by the power of the motor. You will see the behavior of the Tesla battery, how much power they can give, and you will see the voltage drops and how much power does it need for acceleration and for maintaining the speed. And it is also interesting to take this Tesla battery from the original car, and then you will see their behavior in some other application, to take half of the Tesla package and put it into some other cars, how they behave in some other application. They were at 12 degrees. I didn't want to push it too hard, but I reached the maximum speed at that temperature. And they increased the temperature about 5 degrees Celsius. So they were, at the end of the drive, they were about 17 degrees. On the start, they were 12 degrees. So you will going to see what these batteries are capable to give. These are valuable information, and you can see this often, and so I think it is very interesting to see. Today is a beautiful day, but it's cold, so I will going to switch on the heating. And now I will going to show you how I made my LED state of charge light indicator. This is my GitHub repository that you can find down below into the description. You can find here two files. One is the Arduino file and the second one is the schematic. This is the Arduino code and this is schematic. Here are the components: Arduino Uno, LED ring and DC-DC power supply to supply Arduino Uno and the LED ring. This is Arduino analog input signal that reads signal from 0 to 5 volts. We have here 220 volts. This is about, on this side is about 4.8 volt and 190 volt where the battery is low. Then we have 4.1 volt. And this is the third pin digital output that controls the particular lighting. And here is the voltage divider that reduces the voltage from 220 volts to a voltage that is between 0 and 5 volts. With DC-DC are Arduino and LED ring directly powered by high voltage power system, because this power system and this power system needs to be galvanically isolated, so they can't have any physical connections. And now I will going to show you the code. Maybe it looks intimidating, but it is very simple, and this is the exact reading what Arduino reads from this voltage. So I map this segment from 0 to 31 LEDs, and this for loop is decreasing the red light. Here is the brightness, and this for loop is increasing the green light. And now I want to show you how I got this value. So here is the voltage divider calculator. I have my voltage source is 220 volts, and the first resistance in it needs to be high as much as possible. I put 440 kilo ohm. And my output voltage I put 4.8. This is the resistance that it needs to be calculated. So I got here 9.8 kilo ohms. If you don't have these resistors, you can combine it and connect 2 or 3 in series or parallel to get the proper value that you need. You can put here any voltage you want. For example, you can use this code if you have charger, if you need to charge some battery, and if you want to cut the charging at a particular voltage, then you can use this code and adjust it by your needs. If you are not comfortable to play with voltage higher than 100 volt, then it's better not to do. So if you find this channel interesting and if you don't want to miss the next video, then don't forget to subscribe.